With inequalities, we have to remember the four basic signs. We've got our greater than or equal to, our less than, and our less than or equal to. If I have a number, x, and I want it to be greater than 5. If I'm just looking at whole numbers, I know that x can be 6 or 7 or 8 or 9 or any number above that. I can still have decimals, so as long as I start a little bit bigger than 5. But if I have x is greater than or equal to 5, the only difference is that x can start at 5 and then go up from there. And all the little decimals or fractions in between those as well. If I have a particular number that I want to be less than 2, just looking at whole numbers, x could be 1 or 0 or -1, and it could keep going down. But if I have x is less than or equal to 2, then x is also allowed to be 2 because of the equal sign. So it could be 2 or 1 or 0, all the way down. If I wanted to plot x is greater than 2 on a number line, I'd have my number line, make sure I've got a 2 there, put some numbers around it in the right order. Now, because 2 is what I'm looking at, I put a circle at 2. I want the numbers to be bigger than 2, so the arrow goes to the right. If I wanted x to be less than or equal to 3, once again, get my number line, make sure I've got some numbers there in the right order. Now, 3 is the number I'm interested in. It has to be less than 3, so it goes that way, but it's also allowed to be equal to 3. So I want to start at 3. So I colour in the circle when there's an equal sign attached to it. If I want to solve an inequality, it's exactly the same as solving an equation, except for one tiny little thing. But in this example, it's exactly the same as solving an equation. So we want to get the x by itself. First thing we get rid of is the 4, but whatever you do to one side, you do to the other. So you're left with 3x is less than 12. This is really 3 times x. Opposite of timesing by 3 is dividing by 3. 3's cancel, so I'm left with x is less than, and 12 divided by 3 is 4. So any number that's less than 4 will solve this equation. So if you think about it, let's pick a number less than 4, maybe 2. We know that 3 times 2 plus 4 is 6 plus 4, which is 10, and that is indeed less than 16. In this inequality, there's a slight difference, but we'll start the same as always. We've got a 7 and a minus x on one side. We want to get the x by itself, so we're going to get rid of the 7. Do the same to both sides, and then I'm left with minus x is greater than or equal to 3. Now, here's the tricky part. At the moment, we've got a minus 1 times x. So the opposite of timesing by minus 1 is dividing by minus 1. Do it to both sides. But the new thing, if you're dividing by a negative, you have to flip the sign. Why? Because it doesn't work if you don't. Cancel the minus 1s, so I'm left with x. 3 divided by minus 1 is negative 3. So in this case, negative 3 will solve that equation, but anything less than negative 3. So let's just check. If x does in fact equal negative 3, I've got 7 take away negative 3, which equals 7 plus 3, which equals 10, and 10 is greater than or equal to 10. Well, it's actually just equal to 10. So that one works. With this example, I've got a 2 on the bottom, and I'm trying to get x by itself. So the opposite of dividing by 2 is timesing by 2. These twos cancel, and I'm left with minus x is less than 14. Then here, once again, I've got a minus 1 times x. The opposite of timesing by minus 1, dividing by minus 1. Do it to both sides, but because I'm dividing by a negative, that sign has to flip. Once again, it doesn't work if you don't. Minus 1's cancel, so I'm left with x is greater than negative 14. So the rule is if you multiply or divide by a negative, you have to flip the sign.